Sample problem 5. Calculate the pH of the following solutions. So let's start with 0.075 molar pyridine C5H5N. So we have a KB for that. So let's write a base reaction C5H5N plus water. And we get HC5H5N plus and OH minus. Okay, let's set up our ice table. Initial concentration here, 0.0750. No product. Decrease this concentration by X. Increase each of these concentrations by X. So at equilibrium here we have 0.0750 minus X. And each of these concentrations are X. Okay, now let's write a KB expression. Concentration of HC5N5, sorry, that's H5, yeah? So let's fix that. HC5H5N plus concentration of OH minus, concentration of C5H5N equals, so let's see, each of these product concentrations are X, so we get X squared on the top and assume a very small change for the reactant so that X is much less than the original concentration, so that we can say that this is 0.0750. We have to sub in this value for KB to solve for X. When we do that, we get 1.13 times 10 to the minus 5. Now keep in mind that this is your concentration of OH minus. So to find the pH, to do 14 minus the POH, which is the minus log of the hydroxide ion concentration. So we just sub that value in, 1.13 times 10 to the minus 5. We get a pH of 9.05. Now, we're going to do part B. What happens when we add some pyridinium chloride? So let me just make a note here. This pH was 9.05. And most of this problem stays the same. So I'm going to just erase the parts that are different. We'll start with a fresh ice table. KB expression is the same. And we'll redo these calculations with our new values. Okay, so let's see. We start with 0.075 C5H5N, and then this salt, we're told that it dissolves into this, right? So we have a concentration of that from the pyridinium, 0.0850. We have no hydroxide. Our change still minus X plus X plus X. So here we get 0.075 minus X, 0.085 plus X, and X. Okay. So if we assume, again, a very small change relative to the initial concentrations, we can ignore these minus X and plus X and say that 1.7 times 10 to the minus 9 equals 0.085 times X over 0.075. We get an X that is equal to 1.5 times 10 to the minus 9, keeping in mind that this is the hydroxide ion concentration. So to find the pH, we take the negative log of 14, minus the negative log of that. So 14 minus the negative log of the hydroxide ion concentration. 14 minus the POH gives us the pH. And we get 5.18. Less than our original pH of 9.05. As expected, as the equilibrium shifts to the left, decreasing the hydroxide ion concentration will also decrease the pH.